Hey guys, this is just part one of our parallel and perpendicular line notes. Parallel and perpendicular lines we see throughout the world, all over the place, of course. These are just a few examples. This one's kind of a cool example, and I don't know if you realize, but the line here and the line here are parallel, even though they may not look like it with the way the shape is. It makes the lines look like they're not parallel, but they are. Parking lots are great examples of parallel and perpendicular. Bench rails, great examples of the parallel lines and the perpendicular lines. So, with that being said, go to the next page. Parallel lines. And here's the key part of this. Lines that are coplanar and they do not intersect. Coplanar, they do not intersect. You could also, well, coplanar is really important. That fact that if they're parallel, they have to be on the same plane to be parallel. They do not intersect means that they have the same slope. That's the reason they don't intersect, is because they have the same slope. So parallel lines are lines that are coplanar and they do not intersect. Here's a little diagram, and we're going to add skew lines into the mix as well. I know I'm talking about parallel and perpendicular, but skew is another kind of lines that do not intersect as well. Parallel and skew are the only two kind of lines that do not intersect. Parallel are coplanar. Skew are not coplanar. So the difference between parallel lines and skew lines is one is on the same plane and one is not on the same plane. Ones have the same slope, the other ones do not have the same slope, but they don't intersect because they're on different planes. So if you look at this example, you can say that line AB and line CD are parallel because they're on this yellow plane, and line CD and line BE are skew lines because one's going through the plane and one's on the plane and they're not touching anywhere. So those are called skew lines. They're not touching and they're not on the same plane. Now perpendicular lines are lines that form right angles. And perpendicular lines are also coplanar. They're on the same plane with each other. Any lines that intersect have to be coplanar, no matter what. If two lines touch, there's a plane that you could put between those two lines, and they have to be coplanar. So perpendicular lines form right angles. Now here's a little test for you. Can you list a pair of skew lines? Let's see if we can come up with some skew lines. Let's see, we got AE. AE. What would be skew to AE? Well, there's a couple that would be skew to AE. None of the, not AB and not AD, because those are touching. Skew line would be maybe like DC would be a skew line. You see how AE is going down over here on the back plane and on the front plane. CD is on a completely different plane going a completely different direction. Those would be skew lines. Can you list a pair of perpendicular lines? Perpendicular lines, let's use DF. So DF, I mean, we could pick lots of different ones, but perpendicular DF would be DC or FG. Either one would be perpendicular. Let's use DC. We could have used FG. It would also be perpendicular. There's two spots. Those are perpendicular too. And DF is also perpendicular to EF and AD. So also be perpendicular. So there's quite a few there. And can we list a pair of parallel lines? Let's go with AB this time. AB would be parallel to DC. AB would also be parallel to FG. It would also be parallel to E, whatever's in the back corner over there. Those would be parallel. So those are just some examples of some skew, some perpendicular, and some parallel lines. Just a little bit of information, some facts about perpendicular. It might be better if you don't even write these down. It might be better if you just think about it. Maybe just think about it and look at the picture. That might help you to learn it better, even if you don't write it down. You can think about it this way. Two lines form a linear pair. We know a linear pair from before is adjacent angles that are supplementary. So if we can have two angles that form a linear pair and both angles are congruent to each other, that's what these arcs mean, they're congruent. The only way that they can make 180 degrees and actually be the same angle is if they're both 90. That means they would have to be perpendicular. So two angles that are equal, that are going to make 180 degrees, have to both be 90 degrees. Therefore, the lines must be perpendicular. Like I said, it's probably better to just think these through. You don't need to write them down. Just think about them as you're looking at them. If two adjacent acute angles are perpendicular, so we got adjacent acute angles and they're perpendicular, makes a 90-degree angle, then the angles together must make up 90 degrees, so they've got to be complementary angles. So if two angles are touching and they make 90-degree angles, then they have to be complementary. And then the last one, if two lines are perpendicular, they're going to make four right angles. That's pretty self-explanatory. It's like an x and a y-axis. Here's your x-axis, here's your y-axis, and we have an x and a y-axis. They have to make four right angles. Each quadrant would be a right angle there. Just some fun facts. You can just think them over. A transversal is a line that intersects two or more coplanar lines at different points. So it's going to intersect two coplanar lines. This one line is called the transversal here. It intersects these two lines, one at this point and one at this point. It makes 8 different angles. It makes 1, 2, 3, 4, 5, 6, 7, 8 different angles. And 4 of them are special kind of angles. Corresponding angles would be angles that are in the same spot. So like angle 1 and angle 5 would be corresponding angles. Alternate interior angles like angle 3 and angle 6. So like here's an interior, here's an interior, and they're alternating sides of the transversal, making it two different sides of the transversal. Alternate exterior angles would be like 1 and 8. They're alternating sides of the transversal, and they're on the exterior of the two lines. They're on the outside of the two lines. Interior in between the two lines, exterior on the outside of the two lines. And then consecutive interior angles would be like angle 4 and angle 6. Now angle 3 and 5 are also consecutive interior. They're on the left side. These 4 and 6 are on the right side. So those are called consecutive interior angles, 4 and 6 or 3 and 5. Corresponding, you could use 1 and 5. You could actually have used 2 and 6. 3 and 7. 4 and 8. You notice that corresponding angles are in the same position. The lower right corner, or the lower left corner here, lower left corner here. Upper right corner here, upper right corner here, 2 and 6. Those are all corresponding. Alternate interior are going to alternate sides in between the two lines. And same thing with the other alternate interior. 4 and 5 would be alternate interior. 1 and 8, 2 and 7, those would be alternate exterior. And like I said, 3 and 5 and 4 and 6 are my consecutive interior. And that's it for part 1 of your parallel and perpendicular line notes.